Hey there. So the first topic is sol gel method of bottom up method. So we all know what is bottom up method. Bottom up method means first when the vapors of the atom of the metal oxide in that which is condensed where clusters are formed, and that clusters are then added up each other to form a nanoparticles. So that is bottom up method. So in this sol gel method, it is used for non-metals. So first point is sol gel method is a bottom up method. Second point is it is used for metal oxide, and it is also known as wet chemical synthesis. The reason is why it is known as wet chemical synthesis is it is used here water is used as a catalyst. See, first you need to take a precursor. What is the meaning of precursor? Precursor means it is the first material used in the process. In this process, whatever the first material you use, which is metal alkoxide, MOR is the first material you use in this experiment. That's why the first material it is known as precursor. So metal alkoxide is the precursor. Here you need to add water in it. Here because water acts as a catalyst, that's why it is wet chemical synthesis method. So here when you add water, actually metal alkoxide is insoluble with water. To make it soluble, you need to add alcohol in it. So this metal alkoxide, which is precursor, means first material in this process. In this water is added which act as a catalyst, and to make it soluble we will add alcohol. Now we need to stir it continuously, then metal hydroxide is formed. So here okay, I'll write here MOR plus HOH. Here MOH is taken to form MOH plus R, here ORH, so ROH. This MOH is metal hydroxide. So here from metal alkoxide, metal hydroxide is formed. So this process is known as hydrolysis. Now this is first step. Now this metal hydroxide plus is reacted with MOR, metal alkoxide, and then aging is done, means condensation is done. You do nothing here. It takes a lot of time to condense. Then it will form a polymer, which is MOM, means long chain of metal oxide. Metal oxide, a long chain MO is formed. So this is known as polymer plus ROH. As a polymer is formed, this process is known as polymerization. And here, this metal in first reaction, the metal hydroxide plus ROH is known as Sol solution, which is a homogeneous solution. And next is, this is a heterogeneous solution. Next is the polymer plus ROH. This is known as gel solution, which is homogeneous solution. So Sol is a heterogeneous, gel is a homogeneous. First reaction is hydrolysis. Second reaction is polymerization because a polymer is formed. Now here, once again I'll revise it. First step is MOR, metal alkoxide, which is the first material known as precursor, plus water acts as a catalyst, but as both metal hydroxide and metal alkoxide and water are insoluble, so alcohol is added to it. Then a homogeneous solution is formed. Now you need to stir it continuously, then hydrolysis process will take place and metal hydroxide is formed plus ROH. So this is known as Sol. Sol contains nanoparticles of MOH. This is a Sol solution, which is a heterogeneous solution. This contains the nanoparticles of MOH. Now after that, condensation will take place. Why aging is it will take a lot of time to condense. Then after condensation, a polymer is formed, which is MOM, means a long chain of metal oxide is formed, plus ROH. This is a homogeneous solution. So this MOM is a homogeneous solution. Now with this gel, with the help of gel, from gel, nanopowder is made. So the main purpose is to make nano powder. So from that gel only we will make nano powder by using three methods. Any one of the three methods. First method is thermal evaporation. Evaporation. So first step is thermal evaporation. In this, we need to heat the material directly at room temperature and pressure to remove unnecessary materials. So here, in this polymerization, we have all unnecessary materials also in that gel. So we need to remove that unnecessary materials by heating at room temperature. Then zero gel is formed. And here the structure is changed, right? Because here the structure is different from this. So morphology is changed. Morphology means that physical structure and all, okay? So this is thermal evaporation, means heating it directly at room temperature. Here it is known as xyrogel. Here the morphology is changed, means structure is changed. So we don't use it generally, and we mostly we use calcination. Calcination at 100 degrees Celsius. And in intermediate chemistry, we had a differences between roasting and calcination. Roasting means heating in presence of air. Calcination means heating in absence of air. So in calcination, we need to heat the material in absence of air. Then at 800 degrees Celsius, here the morphology is slightly changed, but it's okay. Third method is supercritical synthesis. What is supercritical synthesis? Supercritical synthesis means when we heat at temperature which is greater than critical temperature and pressure which is more than critical pressure. Means here also you need to heat it, but the temperature will be greater than critical temperature and pressure will be greater than critical pressure. Then this is known as supercritical synthesis. Here aerogel is formed. Here morphology is not changed, exactly it will be there. So this is also a best method. So three methods we need to heat it. First method, thermal evaporation, also you will heat it, but here you will heat it at room temperature and pressure to remove unnecessary materials. Here morphology is changed completely and it is known as xyrogel. And here it is calcination. Calcination means heating in absence of air at 800 degrees Celsius. Here morphology is slightly changed, which is nanomaterial powder. Here in supercritical synthesis, here also you will heat, but you will heat at temperature which is greater than critical temperature and pressure which is more than critical pressure. Here morphology is not changed and it is known as aerogel. Here you will heat it at room temperature and pressure will be at room pressure only. Heating at 800 degrees Celsius but in absence of air. Here it is in supercritical synthesis, you will heat at temperature greater than critical temperature and more pressure, means pressure more than critical pressure. Morphology is completely changed. Morphology is slightly changed. Here morphology is not changed. This is known as xyrogel, nanomaterial powder, aerogel. That's it. Thank you. Bye bye.